Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Beginning with step 1, set u equal to the expression raised to the power. That's obviously the x minus 6. So we set u equal to x minus 6. Step 2 says to compute du dx. That's the derivative of u with respect to x, and that would be 1. Step 3 says to solve for dx. So we want to multiply both sides by dx to clear the fractions. That means the dx is on the left, divide out, and you get du equals dx. Technically, we're solving for dx, so some people would be more comfortable writing the dx first, so you could write that dx equal du if you like. Step 4 says if the integrand has a numeric, which is just a number, a constant, factor means something multiplied through, move it to the outside of the integral. And here you see that there is a 2, a factor of 2. The 2 is being multiplied by everything else in the integrand, so move it outside the integral. Step 5 says to substitute both the u and that expression represented by dx into the integrand. The idea is to remove every trace of x and dx, for that matter, from the integrand. So if we take the x minus 6 out and put u in its place, remembering to copy that 2 down, do not forget that 2 is still in front of the integral sign. We get u to the 3/2 power instead of x minus 6 to the 3/2 power. And then since dx is equal to du, if we take the dx out and replace it with a du, we get this integrand, the integral of u to the 3/2 du. Now we're ready to simplify, but that's about as simple as an integral as you could ever have, so there's really nothing to do as far as simplification. Now we're going to apply the general power rule for integration. And again, I can't say this enough, keep carrying that 2 along. If you get caught up in your process and forget to carry that factor along, you're going to be off in your final answer. So it's 2 times what we get when we integrate u to the 3/2 power using the general power rule. The general power rule basically says when you're raising u to a power and integrating that, you increase the power by 1. So we have to add 1 to 3/2. I don't want to make a big deal about working with fractions, but remember 1 is 2/2, so if you add 3/2 and 2/2, you get 5/2. But you also have to multiply by 1 over that new power. 1 over something is just the reciprocal of it, so if we've got 5/2 as the new power, the reciprocal will be 1 over 5/2, which is just flipping the fraction upside down, is 2/5. And of course, every indefinite integral has to have a plus c on the end. Step 8 says to substitute the x values back in and simplify as you need to as you're working through this. As you can see, 2 times 2/5 is 4/5, and if you plug the x minus 6 back in to get rid of the u, you get the quantity x minus 6 raised to the 5/2 power, and then you have the plus c. Remember, we put the u in order to solve the problem. That was not in the original problem, so it has to come back out at the end. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.